Well, thanks for joining me on this. This is the late Pleistocene is definitely outside of my normal wheelhouse, and I can read all the papers I want, but you're going to have much better dexterity with this than I have. Um, so before we get into the Younger Dryas itself, can we maybe talk a little bit about what geoarchaeology is, kind of what pulled you in that direction for
Uh,
that
you
main
know,
focus?
I went to East Carolina University for my master's, and then I went and worked at Fort Bragg, the archaeology program there, for 3 years as a research fellow, postgraduate research fellow. Um, and I think in that time, I just developed a lot of interest. We had Joel Schulderon and other geoarchaeologists coming to work at Fort Bragg, and the kinds of questions that I was interested in, it seemed to me that a lot of them really tied in directly. I needed to know about geology. I needed to be able to integrate geologic methods and concept and principles, and to be able to address some of the questions that I was interested in with regard to early hunter gatherers, Paleo Indians in North America. And so when I went back to East Carolina for my PhD, I was able to sort of set that up with my chair Randy Daniel, sort of a program of study where I would explore sites along the Tar River and try to integrate geoarchaeological techniques and principles to understand site formation, chronology. Um, those are the main issues with the use of luminescence dating, sedimentology, to try to figure out if we can identify discrete packages of strata within these sandy sites where visually you can't see anything.
Right. Yeah. And the bioturbation, when I was looking through your discs earlier, the issues of bioturbation and how that's contributing or isn't contributing to
Yeah,
settling of materials. Yeah, it's some complicated stuff for sure.
it really is. I mean, and I know there's been a debate among several, southeastern archaeologists and geologists for over the years about what exactly we're seeing. When I know some people or some geologists have an idea that the lowest point is a meter deep. Um, for example, would just say at Topper, because it's been laying on the landform longer, so it's had more time to migrate down. Um, but the evidence for that level of sort of mixing I rarely ever see evidence for that. The evidence that I see is bioturbation is a pervasive issue. It's a problem, and it mixes up deposits and causes things to move up and move down. It's certainly an issue for OSL dating. Sand grains are getting blended and just mixed by ants and burrowing animals and that kind of thing, and that's all contributing to this bioturbation problem. But at Topper, and I remember as an undergrad, I got to go work at Cactus Hill
Yeah.
with Tom White for my field school, and that was a profound moment for me. Really, kind of set me on my path, because there we have a sandy site, much like I've worked on most of my career, probably in Aeolian, wind-blown sediment. And very clearly we were coming down as we were helping Joe McAvoy on discreetly buried surfaces of artifacts with with stone hearth pits. And you would, and Joe would excavate that, and they were digging in 2-inch levels. That was how they did it at Cactus Hill. He would go down below that and find another one. It's probably still to this day one of the best stratified sequences I've ever seen in a sandy coastal plain environment.
Yeah,
Uh,
intuitively being in essentially a sand dune, you would think that would be the particulate nature of that sediment would be really prone to that kind of
yeah,
settling and
yeah,
things.
and I think it is. I think that's certainly an issue. But I certainly I don't really see large scale evidence for this sort of biomantle, type situation where you've had essentially non-deposition of these landforms for the last 10 to 13,000 years, and the artifacts have just been mixed and slowly The older artifacts have had more time to move to potentially be deeper, and so you've got this sort of biomantle process, that produces this distribution. I don't see it at that level at all. I mean, there's clear evidence in places where you have severe bioturbation, but in at the same site, you can go over just a meter and find something completely different. It's highly complex. It's highly variable, and you have to really look at it site to site.
Yeah. There was a site that I did a couple of years ago, that the issue there was vertisols, where you could
Yeah,
actually see the vertic cracking. And so
yeah,
all the
right,
artifacts were coming at the very bottom of that, and they were all vertically.
absolutely,
Where so like it's
right,
when you have things like this, it is generally you can tell if you're really paying attention and taking good notes on
yeah,
the orientations, the materials you're finding. You can see when
yeah,
these kinds of
yeah,
settling behaviors.
right. And another thing that I've seen, I mean, intuitively, I've seen this, and I've certainly noted it many times in the field. In sandy sites, really small debitage and flakes can go way down,
Yeah.
well below the base of what I consider the bottom of the earliest prehistoric component. But the larger stuff doesn't do that. Typically, it just doesn't do that. It's staying much more stable. You're able to identify, what I would call a surface or a zone, a stratigraphic zone within these sites with larger artifacts, cobble tools, hammerstones, large bifaces, things like that. Um, Another site I worked on for my dissertation, you may have seen the Squires Ridge
Mhm.
on the Tar River. That's probably, for me, uh, one of the best since Cactus Hill in terms of having really just nice, discrete, stratigraphically, stratigraphic zones, with different occupations. Um, but even there, we have issues. Things get mixed up from place to place, and the problem in these sandy sites, they're leached. They're visually, you can have a pit, you can have a later prehistoric pit intruding into an early archaic occupation zone. Visually, you may not even see it. Right.
Yeah.
So those are the issues.
Right.
Um, I've worked with Mark Brooks a lot on sites. We've talked about this issue, the whole bioturbation issue, and we've often said, just talking, that anthropogenic turbation from later occupations is probably the major, is even more of a disturbance vector than ants and critters in most cases.
Yeah, that's a whole separate can of worms too, because like in
Yeah,
the rock shelter sites that I've done most of my research work on, it's like you get into that middle archaic period where people are starting to dig out all these pit features, and
absolutely.
that's causing uh, all kinds of disruption that makes things much more difficult to interpret and analyze without like really, really
Yeah,
fine grained excavation
right,
methodologies.
right. At Flamingo Bay, I worked at on the Savannah Riverside. We've got Clovis occupation there all the way through Woodland and Mississippian. Um, there's lots of evidence here and there of middle archaic pits. The only way we can tell is very close excavating with a trowel. You can see tiny bits of nutshell, hickory nutshell, no soil color change at all, and you can trace those nutshells in pit shape features.
We've
Um,
done that before, actually, out here in Arkansas, where I am now. There was a
yeah,
site where like it was the same thing. You couldn't really see features, but I started to get little bits of nutshell, and so I started pin flagging those and
yes,
taking
right,
photographs as I went down, so that we couldn't
right.
really cut profiles on them so well, but we could then kind of reverse engineer the shape of those pit features.
Yep,
Um,
that's right. Same thing.
okay, so getting into the Younger Dryas itself, because this is kind of it's a period of like human extremes, the extremes of human experience, and so it definitely kind of captures the imagination. Um,
Oh yeah,
let's kind of go over what was going on in North America before the onset of this, and then get into like what happened at that shortly after 13,000 years ago point.
yeah. Right,
So we're talking about Cactus Hill and then later Clovis culture.
right. Right. Well, I mean, you want to just specifically talk about possible pre-Clovis cultures, or just, I
I mean,
mean,
always cool to talk about pre-Clovis cultures. Because like when I was an undergrad, Tom always brought up Cactus Hill because I
yeah,
worked there and he knew it really well. Um,
right.
but my
I mean, those are, I mean, what are those are radiocarbon dated? He's got, I mean, Joe McAvoy has dates that are, that calibrate
16
what?
to 18.
Yeah, 16 to 18,000.
Yeah,
So this you're getting back close to the last glacial maximum at that point. LGM kind of stuff, which is interesting because we're now, now we've got the footprints at White Sands. A lot of this is, minimally published, but we've got, the site like Parsons Island
hmm
that Darren Lowry's worked on, and some others have been working on more recently. It's not published yet, but I mean, it's known from earlier work. They've got a deeply buried paleosol there, extensively dated to the LGM,
yeah,
20 to 22,000, with artifacts washing out of the profile.
right.
Very clearly, pictures of them sticking out of the wall. This is an island that's being heavily eroded. It's going away very fast. The profile there is collapsing into the water. It's receding. And as it does, there's artifacts coming out of this paleosol, and it's been tied to this whole, Stanford talked about the Salutrian idea, Stanford and Bradley. I mean, whatever it is, it's something that it's real. It's something there. And it's very clearly within, um, stratigraphic context of LGM age.
Yeah.
Again, so
Just if you were to like back a particular horse, would you do you think that boats were involved in those initial migrations, or do you think it was people getting through the ice-free corridor before it closed rather than after it opened up, as has been the traditional model?
I'm a big fan of boats.
I
I,
always have been too, and that seems to
I,
be where most people are going with this at this
I mean,
point.
it's one of those things that's like, there's no evidence, we just, except, that we have people in, you know, other parts of the world getting, to Australia or to whatever, but and it looks like at times when there was no land route, they had to. So I think, I mean, I always we want to find evidence before we make statements about things, right? But I think we're doing a disservice to the intellect of our ancestors. I mean, I think these people would have had boats, and probably in certain areas would have had maritime adaptations
And
far
also just
longer.
by process of elimination, like, okay, they don't have boats when they first get into the continent, but somehow they figure out boats on the way down to Chile
Yeah,
and Monteverde. Like, it
yeah. I mean,
makes entirely more sense that they're using boats to
I'm
figure out.
I'm open to a whole lot of things now as possibilities. I mean, but again, as we see with a lot of popular things that get put on cable, or on Netflix series or things like that, a lot of things is put out there without any evidence. And that's something that's, as a scientist, I don't like to do. But I think if we're just for speculating, I mean, that's a very reasonable proposition that humans have had bow technology for probably far longer than we think.
Well, they're perishable materials, so it's the
Right.
preservation is an absolute crapshoot.
Right.
What do you think has anything new come out regarding Chiquihuite Cave, that cave in Mexico, since we had
Yeah.
those initial conversations?
Not that I've heard. No.
Yeah, the I fully believe that the possibility of people being here 30,000 years ago
Yeah.
is a possibility. I just don't like the evidence that they presented in that paper.
Yeah. Yeah.
Um, but I'm also not a
Yeah.
paleo specialist, or a geo specialist, and that's really the main thing for that paper, I think.
Right.
Um, okay, so we've got longstanding habitation of the continents. Um, and then we get this like kind of uptick in visibility really with Clovis, because the
Right.
Clovis points are so um, they're so distinct it's hard
Yeah.
to recognize them for what they are. So even if you don't have dates to demonstrate what they are,
Right.
you can look at them and you know that's what this is.
Right.
And
Exactly.
on the back end, we've got all these radiocarbon dates that show this really tight chronology on those.
Right.
So what's going on there in terms of environmental conditions? I've got a little bit of environmental data from coming from like Coppola Pond that's showing kind of a transition. They call this like a no
Yeah.
analog environment where you've got
Yeah.
these like spruces intermixed with oaks that
Right.
you don't really see anywhere in the
Right.
world
Right.
today. Um, what
Yeah.
so you're like more Eastern Carolinas oriented though. So like what's
Mhm.
going on over there?
I mean, the Booling Alurod period is when, Clovis emerges, at least in terms of the archaeological visibility question, which I think is you raised, which is important because, you know, when this whole pre-Clovis debate, if we have populations here 20, 30,000 years, um, there's a few issues. One is the archaeological visibility question, very small groups perhaps, and also what kind of tools are they leaving behind? Like you said, the Clovis is very recognizable. But yeah, the Clovis people, when they, how they spread out through North America, or the spread of the idea, the technology, to pre-existing small groups of pre-Clovis people who adopted the more or less the Clovis techno-complex, that we see over North America. That occurred during a time when we were coming out of the glacial period. We were warming up from the last glacial maximum quite a bit. Um, we did have these non-analog period of climate with different ecosystems. We certainly at White Pond in South Carolina, the work of Watts, the pollen work of Watts certainly shows that same kind of thing at White Pond. Uh, but I mean, how warm was it compared to today? I don't know exactly that we know. But it was certainly a time period. All the climate indicators indicate, that the climate was ameliorating. We were coming out of the ice age. The glaciers were, beginning to in retreat. Certainly by the time Clovis people were here, in many ways, the climate could have been very similar to what we have now, with the exception that they were still probably, looking at environmentally, this spruce, pine, fir type of ecosystem around White Pond. Certainly, but in the LGM period, we have periods of very sparse vegetation. We had dunes blowing all around the southeast along our rivers. Some of the Carolina bays were probably more active here. With the sand rims around the bays being more active during that time, because you had much less vegetation. You're going to move sediment around. Um, it's going to free it up. If you have fires, it's going to release it even more. Certainly, the work of Chris Sweezy and others have showed during the LGM, we had incredibly strong winds, which again, we see clear evidence for with parabolic dunes and dune fields all along southeastern rivers, right? So just incredible dunes that, in many cases, until the advent of LiDAR, we didn't even realize how common these were. And now with LiDAR, these things are just all over the
Yeah,
place.
you can actually see them with the LiDAR.
You can see them, and they're incredible. Some of the things I'm still scratching my head about exactly how um, some of the dunes have formed. But yeah, you see them everywhere, and most of that formation is probably based on the work that's been done by David Lee, Andrew Ivester, people like that, is in the, 20,000 range, 18,000, maybe some of them older. But by the time Clovis was here, a lot of that was probably getting shut down
Right.
because you
And
had
what I've been
increased.
seeing with it too is like around 18,000, you start to see, because like there's that inverse relationship between the sea level and the glaciation. And so like the
Yeah,
glaciers going down, the sea level coming
yeah,
up until that Younger Dryas incident
right.
where things start to reverse, the glaciers start to
Yeah,
come back for a little bit, and the sea
yeah,
level kind of stagnates. In fact, might
yeah,
actually go down a little bit.
yeah. Yeah, I mean, certainly, at the YD onset in the northern hemisphere anyway, certainly from the ice sheet, from the Greenland ice sheet, that there was certainly a return of much cooler conditions, a return of glacial conditions in places. We see evidence of mountain glaciers actually that were retreating start to grow again. But I think that's highly variable. I think the climate system, I think we've got Younger Dryas sites in South America we've been looking at, and we've got colleagues that have been looking at, and it's anti-phase. It was warmer. It got warmer, or it looks like it got warmer down there, but it was a climate event, that happened that was going on at the same time. The onset was extremely rapid, right around 12,800 years ago. I heard a talk by Jim Kennett a few years ago. He was saying that the ice core data that they've been able to look at, the high resolution ice core data, shows potentially the Younger Dryas initiated in less than 1 year, which is a little bit different than what we probably have seen for some of the earlier, events that we see during the Pleistocene, that are likely Younger Dryas.
And with archaeology, normally we don't normally have that resolution of a year. Like we're lucky if we have resolution within like 3 decades. So
right, and that's the problem. Myself and others we're interested. Regardless of whether you think that an impact occurred, we know the Younger Dryas climate event occurred, and what effect did that have on humans? What effect did that have on Clovis people? A lot of people are really, a lot of my colleagues and myself included are interested in that question, and have been trying to address it through excavations, Mingo Bay and White Pond. But finding Clovis artifacts is extremely rare in South Carolina and pretty much anywhere else. And so just getting the data we need to begin to answer, or to try to answer the question of, how did it affect humans at that time, is extremely difficult, not only because of our issues with temporal resolution, but just finding the sites.
So, getting to like kind of the elephant in the room on the impact. I first heard about this from Tom White at SEAC, probably like 2016 or something, where he brought up the paper that I think you published in 2017 with some colleagues, focusing on platinum. And all the stuff that I read on, it looks really good. Like platinum is not, it's a rare element.
Yeah.
And it is most abundant out there in space. So if we suddenly have this massive blanketing of platinum,
right,
either it's like being synthesized by something which is normally requires like solar level activity to create, or it's coming from out there. And the most parsimonious explanation for that platinum is definitely an extraterrestrial impact.
Right.
So why don't you talk about the platinum first and the platinum group elements, and then we can get into like spherules.
Well, a group from Harvard, the Patev et al. Paper that was published in 2013, they went to Greenland, and I think I don't know if you know the late paleoclimatologist Wally Broker, who passed away I think a year ago. He was really big and very well respected. Done a lot of work on understanding the Younger Dryas. He was a skeptic. He thought, he didn't think that there was an impact, and I think he worked behind the scenes and kind of supported, the work that the Harvard team did, and said, okay, this group says there was an impact at the beginning of the Younger Dryas. Let's go to Greenland. Let's look in the ice at this high resolution interannual layers of ice, and let's see if we can detect elements that might be consistent with an impact. And I think initially they were looking for iridium, right? Iridium is sort of the one that most impact scientists think about when they think about an impact, the KPG boundary, the dinosaur extinction event, right? The iridium layer, right? That's found globally, right? Which indicates that that dinosaur extinction event, the asteroid that hit in the Yucatan Peninsula. And so they went in and they collected the ice needed to do that. And they developed techniques to be able to detect these at a very, very low amounts. What was interesting with the Patev paper they didn't find much iridium. They found some, but what was interesting is they found highly elevated platinum. And not only that, but they could see the rise in the ice and then the decline over a period of, I think, maybe 13 years, which is consistent with the input of a source of platinum into the atmosphere, into the stratosphere, and then the rain of that material out of the atmosphere over a number of years. So it rises to a peak in the ice and then declines. And that's what they see in the ice. And I know for Wally Broker, before he died, he came around and said, hey, I believe this. I believe this now. I think there was an impact. I think there was a comet, a fragmented comet, or something that impacted with the Earth. The evidence from Greenland, in his view, was incontrovertible. I mean, so he accepted it. Now that doesn't mean he accepted all the things that we think may have occurred after the impact, but I think he accepted that there was an impact. And so the platinum, elevated platinum, was something that, from the original Firestone 2007 paper on the Whitey impact hypothesis, iridium and platinum and some of these things have been reported elevated at various sites, Clovis sites. And so with that in mind, and I had finished my dissertation in East Carolina. I had all of these sediment samples from all these different sites I'd excavated, that I had a pretty good idea that it included probably the Younger Dryas. I didn't have any Clovis sites, but I had soil that went through. I was pretty certain, based on the dates and the depth that I was working, that would include the Younger Dryas. And we even had some OSO dates that suggested that. And so I took those. I took site samples that I had collected since I came down to work at the Savannah River Archaeology program. I worked at Flamingo Bay. I got samples from the Kolb site on the PD in South Carolina, sampled other sites on the Savannah River, Carolina Bay sand rims. So I'd worked on as a separate project. So I had all of these different samples, and then there were samples out west, Murray Springs, Blackwater Draw, Arlington Canyon. So we collected samples from all of these, and I sent those off, and every one of them came back with platinum anomaly, at least a small anomaly, either within what we had already dated very precisely to the Younger Dryas, or what we had inferred would be the Younger Dryas onset time frame.
Cool. So pushback on this, when we're taking early archaeology classes, there's a lot of talk of early archaeologists tried to blame everything on big catastrophic events.
Right.
It was just kind of seen as a lazy lack of evidence explanation for internal social processes that cause culture change instead. But this isn't that scenario. The data on this are much more robust. So it's not just the platinum. You've also got these nanodiamonds and the microspherules that are, as far as I understand, produced by very high temperatures in a vacuum of materials being essentially melted down in a vacuum to create these bubbles.
Yeah, that's right. Mm-hmm. Yeah. So, the evidence, the various proxies, that were reported, the microspherules and nanodiamonds, platinum group elements, iridium, chromium, lots of different things have been reported. Carbon spherules, fullerenes, all kinds of things have been reported in various sites. All of that is certainly, I think, strongly suggestive of an impact. But again, how that affected the climate system, was it the cause of the Younger Dryas climate shift? I mean, I think I feel pretty confident that it was. I think that it had indirect measure of doing that by probably, some of these objects, I think it was a fragmented comet. We've got evidence in South America. We're getting things at sites down there that this couldn't, the impacts in some of these sites couldn't have been way off. They had to be close. And we're seeing that at various places. So this really is looking more and more like a fragmented comet, like Shoemaker-Levy 9 that hit Jupiter a number of years ago. Just boom, 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 boom. On Jupiter, something similar could happen here and distribute spherules, nanodiamonds globally in the ice, the platinum, right? but and so I think the evidence for that, I think that we're coming around to possibly the consensus that that is most likely what happened. Lots of details to be worked out, um, and still, not accepted by everyone that that's that this happened. So lots more research to be done. But even that, even accepting that we were hit by a fragmented comet at 12,800, if you accept that that caused destabilized the ice sheet over North America, perhaps it caused massive floods. It shut down, the Gulf Stream thermohaline circulation. It led to this rapid climate shift in the Younger Dryas. If you accept all that, you're still left with what effect did it have on the environment? What effect did it have on people? Did it really, have, catastrophic effects on Clovis in North America? That's a debate that's going to go on maybe longer than the debate about where we actually get by comet, right?
Right. And like it's not like there's a clean like break from Clovis to Folsom, and even the
Yeah,
concept of that is kind of weird because like Folsom is really just smaller Clovis with a longer fleet. It's a very
yeah,
clear descendant thing, and
yeah,
the
yeah,
Buchanan
like redstone points,
yeah,
right?
in Cumberland and
Yep.
and all of these. But so like in the paper that Buchanan and Kilby and all their colleagues put out a couple of years ago, where they reanalyzed a bunch of radiocarbon dates that are finding that Folsom looks like an offshoot that happens about 200 years before Clovis
Yeah,
begins.
yeah,
So
right,
there's good cultural continuity going through this.
right, right.
Um,
Yeah. So, no, there's been a lot of things thrown around. The demise of Clovis, the end of Clovis. You know, I don't see any clear evidence of that. I don't think that people were wiped out. I think that there was continuity. Um, but again, a lot of this gets back to our ability to see what's going on at decadal scales, or even at century scales,
yeah.
is so difficult in archaeology for this time period. So we're using, you've seen the work Anderson et al. The sum probability of radiocarbon dates, to suggest, there was a demographic shift or population
Certainly looks like
decline.
a dip, but it's not like everyone's suddenly gone. But it's like in the
No,
worst
no,
regions, it looks like about 50% or something like that. Um,
right, and even that is, I think, is still controversial and still speculative because of our lack of resolution in many
right.
cases. They argue that the big chert quarries, like what we have in South Carolina on the Savannah River, there was some period perhaps of abandonment, or at least it wasn't being used as intensively between Clovis and later groups. Al Goodyear has done, the fluted point survey for years in South Carolina and surrounding states. We seem to have, four and a half Clovis for every one redstone, right? So there's this idea that you're looking at simply points alone, which has its own problems, but
Right.
looking at points alone, you would say, well, it looks like maybe there was a big drop in population immediately post Clovis because there's so many fewer redstone. Of course,
But it
we
could
don't
also
have
just
any
be they
dates.
diversify their toolkit so they're not all being like defined by this one tool
Yeah,
type.
yeah,
And
right. So that's a problem. I mean, I think all of these have problems. I think the sum probability work that Anderson and others have done is, and I think it's really interesting. I don't know, it may be the best we can do in many cases
yeah.
to figure out what's going on, in terms of number of people on the landscape. Um,
So in terms of like direct reactions to this proposed impact, the first thing that comes to my mind is if it's hitting a glacier or if it's hitting maybe somewhere in the ocean where we can't see it, that's still
yeah,
putting a lot of water up into the atmosphere
yeah,
that is
that's
going to
right.
manifest as thunderstorms.
Right.
And one of the things that we see afterwards is an increase in burned botanicals and soot
Yeah.
deposition, which
Right.
looks like wildfires. And one of the papers that I looked at that you had sent me is projecting something like a 9% of at least northern hemisphere biomass
Yeah.
being burned all at once. So uh,
Right.
there's a causal link there between an impact, thunderstorms, and increased forest fires. So this
Yeah.
also, I mean, it's not case closed proof positive, but
No,
there's
no.
a reasonable line of thought
Yeah.
between those two phenomena.
Oh, sure. Yeah. The Walbach et al. Paper, which I was one of many co-authors on that. But we looked at cores, marine cores, and terrestrial cores, and ice cores, from all over the world, and you don't see the same evidence in every one. But in a lot of these cores, there's a pretty major peak in what's called combustion aerosols,
Hmm.
ammonium, and nitrates and soot and charcoal. I mean, all of these things were being seen right at the beginning of the Whiting onset in a number of these records core records that's been looked at. That's the largest in in many cases the largest in maybe 100,000 years of the records that have been looked at. It's the largest event of burning, um, and that's debated, and that's those papers that have come out that have looked at cores in different ways and come up with different interpretations. But um, if you accept the premise, if we burned as much as 10% of the global biomass, perhaps very rapidly at the beginning of the Whiting onset from the impacts of fragmented comets. And by the way, many of these may have just been airburst. They may have
Right.
not hit anything. They may have exploded in the atmosphere. That would,
Or melted from the friction, so there's nothing physical left, but it's still a lot of hot air that's
yeah, yeah.
hitting the surface.
And if for whatever reason, if the airburst, all over the globally create many of the wildfires that led to the burning that we see, the biomass burning, or the disruptions to the atmosphere, and storms and lightning, all of these factors could be factors. But if you burn 10% of the global biomass and you do it rapidly enough, you're probably going to create an impact winter.
Hmm.
You're going to obscure the sun for a period of time, weeks, months. We don't know. But I think it just follows that if you're burning that much, it's going to have a pretty severe atmospheric effect.
It's a lot of
Uh,
smoke that you have to account for at that point.
a lot of smoke, a lot of soot, and some of this is being injected into the stratosphere
Hmm.
if we're having airburst. Um, so so that was, I think, a really important paper to show, to really begin to get it. Okay, if you accept that there was an impact, what did it do? What were the climate effects on at that time? And that's one possibility, is that we had an impact winter. So in addition to all the burning, we obscured the sun for a period of time.
And on top of that, you've got all these like megafauna who have to respirate at a much, they need air.
Yeah,
And they're also most of them are herbivores.
yeah,
So if that, botanical mass has been burned, they have nothing to eat. So
right.
they're probably getting hit from multiple sides in
Yeah, that's
ways
right.
that smaller fauna are not under nearly as much stress.
Right, right, exactly. So, you've heard the was it 32, 34 genre of animals, are basically all extinct by or around the Younger Dryas. We
Extinct
know
or
that
extirpated, they
right.
like
Some
from
of them,
most of the area, yeah, for
yeah,
sure.
yeah. So again, I think that gets back to the idea that the extinctions, maybe the dinosaur extinction event was different, but I think generally the extinctions are complex and they don't happen like that. It
Right.
takes. We know that some proboscideans, survived in various refugia and islands, as much as up to the mid Holocene in places.
Yeah.
So they were, regionally extirpated. There probably were, who knows how long they survived in pockets, perhaps in North America. I think that's going to be a debate that goes on for a long time. Um, but yeah, generally, I think many of these animals, the Pleistocene megafauna, were going out or extinct around the time of the Younger Dryas. Again, that's another complex issue that gets to our resolution about dating. To
Right.
understand, did they really go extinct right at the Whiting onset? But so that's another thing we have to look at. But yeah, I think and again, there's a whole debate over that we keep seeming coming back to the whole overkill scenario. The idea that did humans come into North America and wipe out many of these animals, and I don't discount that they could have an influence on that. I think that the complexity of extinctions, humans probably had a role in the extinctions post impact. I think that the climate changes, the impact winter, the biomass burning that occurred at the beginning of the Younger Dryas, along with humans trying to survive that, and perhaps going after remaining herds of animals of megafauna a little more intensively in various refugia. I think all of that could be a factor in the extinction process.
And looking at it from perspective of like optimal foraging theory, overhunting doesn't make a whole lot of sense if there's not other contributing factors going on. Because if people can't get the high rank resources easily, then they tend to prefer to spend their time on other lower ranked resources.
Yeah.
So
Yeah.
actually driving these animals extinct strictly from overhunting without there being some pressure for them to keep fixating on these taxa doesn't make a
Right.
whole lot of sense based on
Right.
what we know about how foraging societies operationalize their landscapes and their environments and the
Right.
taxa that live on.
Right.
So I think your 1-2 punch model actually that you talked about before actually makes a whole lot more sense if we need to even invoke overhunting into the
Yeah.
equation at all.
Right. Right. And and I know people disagree about that too. I mean, I know there's certainly people that are essentially still supporting this overkill idea that is the mechanism of extinction. Even I think recently there's been papers that have basically supported that idea. Um, but I think it's likely to be a lot more complex than that.
Yeah. And the overkill, based on all of the archaeologists that I talked to, it's not really a popular idea among like.
No, I don't think it is. But people still talk about it, and
same thing with Clovis first. Like I think I can count on one hand the number of Clovis that I know.
Right. So I mean, again, these are questions we don't really know the answers to yet. So we're kind of speculating here. Maybe in another 10, 20 years we'll have different ideas. But I think for now, I mean, if I had to bet on what I thought happened, I would say that I definitely feel that that all of these things figured together. The environmental effects from an extraterrestrial impact of a fragmented comet globally, the burning, the removal of biomass, for many of these large megafauna that depended on that, and then humans, trying to survive, may have had some limited role in, pushing some of them to at least, extirpating them from the region, or then eventually extinction in some cases. But but these are questions we still don't really have a good handle on. And I don't know how long it's going to be before we do.
So something that I just thought of, like literally just now, we see, I've read news about like elephants being under extreme stress, becoming more violent.
Mm-hmm.
If these megafauna are under extreme stress, they may become more violent, and that might also be a pressure that causes people to decide we don't want that animal around anymore.
Yeah, well, yeah, good point. It's hard to imagine. You see the images of Clovis hunter gatherers engaging point blank, with a mammoth, and surrounding them and using throwing an atlatl or whatever into the. But that's an extremely dangerous endeavor.
Yeah.
And we know in many cases where they could do it, they probably would run the animals off of a cliff or something like that. That's a lot less dangerous. But yeah, I mean, that's a good point. I think there may be cultural reasons why some of these animals were hunted. Right. I think there's Mike Grangley and others have put forth ideas that there was essentially a cult of the mammoth that is derived from even as far back as the Gravettian.
Mm-hmm.
Again, speculating that there was this, that Clovis hunters, were, mammoths and other proboscideans were part of some religious, cultural belief that they needed to be took for various reasons or at certain times, maybe at a level that is even beyond what would be needed for subsistence, or what would be done if you were trying to avoid, dangerous animals.
Right.
So, and of course, these are extremely hard things to figure out from the archaeological record, right? How
Right.
do you get into the mind of people, from 13,000 years ago to understand, or were these things that were elements of their belief system? And, that's
Kind
those are
of beyond the scope of what we can really talk about, certainly right now.
right. Yeah. I mean, at least in the old world in Europe, at least they've got, lots of, a lot more sort of the cave paintings and, portable art, and that kind of thing. That maybe indicates there was some focus on, or at least fascination with some of the megafauna, which you could understand.
Yeah.
You don't really have that, with very few possible exceptions in North America.
Right.
Um,
I think Jan Shemek, I think the earliest ones he talks about are from the Archaic.
right.
They're
Just,
very sparse, but also,
right.
admittedly, we have not been looking for cave art for very
Yeah.
long.
Yeah.
Out southwest and out west, it's a different story. But where we're at, I mean, I've got a really good friend who's a PhD who she's working on
Mm-hmm.
Mudcliff Cave in Alabama, which is of course fairly late. I'm pretty sure that's mostly Mississippian, but yeah, like we haven't really been looking for that cave art for very long. We've had much different,
Yeah. Right.
more proceduralist questions that we've been
Yeah.
really focused on for the,
Right.
you know, last 60, 70 years.
Yeah. Right. Yeah. I mean, we don't have much of that. I'm probably not the best one to summarize some of this, but there are Native American oral traditions from various groups all over North America that people have, I've talked to Native American groups and they've gotten stories, which in some cases you might, speculate are they talking about something that happened millennia before? There are descriptions of things that in various Native American groups that suggest, maybe there's, some memory that's been passed down of something like the Younger Dryas Empire. There's things that are this kind of hint of that possibility. Again, it's one of these things. How do you ever really do much with that?
Right.
How do you really say that that's really tied to something that happened 13,000 years ago? I don't know.
Like,
But
how do we
it's certainly
date that?
intriguing.
Like,
Right.
yeah. But like, and people might want to dismiss the oral histories, but if you're talking about a situation where, like, anytime anyone tells the story, everyone else in the room already knows the story,
Yeah.
so they're going to call you out on it if you're being unfaithful to the story.
Yeah.
Imagine if, like, you went to church on Easter and the pastor said that Jesus was beheaded instead of
Yeah.
crucified. Like,
Right.
everyone
Exactly.
there knows that's not how the story goes. So
Right.
it's much harder for these kinds of, like, deeply rooted traditional stories to
Yeah.
get the nuts and bolts changed.
Yeah. I mean, and you can imagine, if something was a global event and it's catastrophic in many places, you can imagine how that might wind up into a very long-term, oral tradition and story that is able to, survive for millennia in some form, right? So
The problem is
I mean,
data.
exactly right. So again, they're tantalizing and they're interesting to hear about, and there's lots of them, lots of stories, and that I looked at and wondered if they are related to something like the Younger Dryas Empire, but we can't rely on that to prove anything.
Right.
So we need more evidence. We're planning the trip right now to Greenland. We're hoping to be able to do that in July.
Cool.
To collect ice directly from the edge of the ice sheet where the Younger Dryas, there's a dusty layer that is or melting out of the edge of the ice sheet in Greenland that is from the Younger Dryas period. And it's clearly, recognized by the glaciologists. We're going to go there. We're going to cut large chunks of ice out of that, and we're going to test that ice for many of the proxies that we've previously talked about, some of which has never been looked at in the Greenland ice.
Okay, cool.
And the problem is a lot of the cores that have been done for the paleoclimate reconstruction, in many cases, the part of that ice core that is the Younger Dryas, it's gone or there's very little left. And so looking for microspirals or looking again for the nanodiamonds or looking for soot, the pyrogenic carbon, really hasn't been done for the Younger Dryas, right? All of these things that we think are related to the impact haven't been looked at. The platinum has been looked at. We're going to do that again, but we're hoping, to collect a bunch of ice, and it's going to be a lot of different people, scientists involved looking at this. Not going to be just one group.
That's a cool project. I'm looking forward to seeing how that turns out.
So we've got glaciologists on board. We're getting cores from the same area, as well as chopping pieces, big chunks of ice from the edge of the ice sheet there. We're actually gonna. This is something that I'd never even thought about until recently. Apparently, if we can actually get a big piece of ice, you can take that in the right conditions, melt it, collect the CO2 that's trapped in the ice, and date the ice.
Okay.
With carbon dioxide gas. So we're going to try to, that'll be we use that to verify that the layer that we're sampling is really the Younger Dryas. So there's lots of things that we have planned to do. And again, this is going to be more of a continuing effort to get at exactly what happened. And among those skeptics who still don't want to accept that there was an impact, I think this will be important if we can replicate, these proxies from the ice. The Greenland ice is kind of the gold standard of paleoclimate reconstruction, right? Anything in the atmosphere falls on the ice, is covered up with snow, it's compressed. You don't have a lot of opportunity for contamination there.
Right.
It's so we're planning to do that. Stay tuned. Again, I think the debate about what exactly the effects were on humans, that's going to go on for a long time.
Right.
Even if there eventually is a consensus that there was an impact.
Yeah. Well, if there was, it certainly wasn't. It certainly wasn't nothing. I think we can see a few indicators from that Anderson et al. Paper that there was, if not a demographic decline, certainly a demographic reorganization. You can see that with like the Clovis to Folsom, where like the hotbeds of Clovis are in different spots on the map compared to the hotbeds of Folsom, where they seem to have moved from east into the Rockies.
Right. So all of those are interesting, sort of tantalizing clues about demographic change, right? And change, over the landscape. What are people doing? The whole issue going back to in the east in South Carolina, the whole issue with the redstone, right? Which is, we consider that essentially the same time period as Folsom. These full fluted, deeply incurvate based full fluted points. And again, it's clear that there's far less of them than Clovis points, but we don't have a handle on how long were they being made, right? Mm-hmm. There's possibly a few dates from Cactus Hill that was published in the last Cactus Hill report that came out a few years ago for these deeply incurvate based points that indicate, if they're redstones, that it's right at the very, very end of Clovis. But we don't know how long redstone points were made, right? There was a debate about Clovis. Was Clovis 300 years? Was it 600 years? How long was Clovis being made? But we have a lot better handle on that. We don't have a handle on how long redstone points were being made. And so if redstones were only being made for 100 years, and then there was a transition to Dalton technology, then there's going to be a lot less redstone points. So again, these are issues of limits to our resolution that seem to take decades to even begin to address in terms of getting dates on finding these artifacts in a context where you can actually get dates.
Right. Because so often redstones and like Beaver Lakes and Cumberlands, they're being found eroded out of like the Tennessee River and shit like that. They're not,
Yeah.
you don't find those on sites very often.
Yeah, right. Exactly. Extremely rare to find that, which makes all of this so difficult, which why we wound up speculating about with very limited data, right? I mean,
Right.
that's what
So
we have.
I know that obviously like in the Paleo period, they're not really doing a whole lot of heat treating, but um with because it's a cryptocrystalline, could you hypothetically do TL dating on points that are heat treated or burned? Like if you get like Clovis age material or paleo material that's burned, can you do TL dating on it?
Yeah, I mean, I think you can. I think some of that's been done, and I've certainly thought about it, talked about it over the years. I haven't done it. I think the issue with TL of lithics is not that whether it can or can't be done. Is it's the same thing with OSL dating, optically stimulated luminescence dating of sand. From that period, you're going to get a large standard deviation. Your error is going to be very large,
Right.
and it's probably going to be so large that it's almost
It doesn't tell you anything.
it doesn't tell you very much. I mean, it's when I take OSL from soil profiles, they're useful. You know, they get you they give you an idea in the ballpark. You know, at Wakulla Springs, you know, I've got OSL in many of the profiles there, right?
Mm-hmm.
And I'll have a series of OSL samples, and in the middle of that, I'll have my big platinum peak, which I'm interpreting as likely to be 12,800 years ago. And the OSL dates, you know, that I've been getting bracket that. They support that claim.
Right.
But, you know, you might get a, you know, 13,000 year OSL date, and it might have a 1,200 year sigma.
Right.
So in terms of addressing how long some of these points are around, it's probably not going to be very useful, unfortunately.
Okay.
There's another thing I will mention this, and because I'm interested in doing this. There's a technique called fluorine diffusion dating that I'm interested in trying to do on stone.
Okay. Is this the same fluorine dating that we were talking about like 15 years ago, where it's like a relative dating method, or is this something more precise than that?
I don't think I'm not sure we know. I think that I saw a presentation a few years ago. So there was a PhD student talking about doing fluorine diffusion on stone tools. He was arguing that he thought it could eventually get approximately something like a radiocarbon date, right? But that remains to be seen.
Right.
Whether or not it would get to the level of being sort of an absolute dating versus a relative dating technique. But you know, I mean, if you can date, you know, once you know with a piece of chert or whatever it is, when it's being flaked, it's resetting the clock, right? It's removing those flakes, and you have the diffusion of fluorine atoms into the surface of the tool. It reminds me of like obsidian hydration in a sense.
Right. Yeah, I was just thinking that.
But if that can be measured precisely on enough artifacts, you might be able to model the ages of various points. You know, if you wanted, we might be able to date redstone points. We might be able to date versus Clovis and some of these pre-Clovis tools that we're finding that we have no ability to get precise dates on. But then again, none of this has really been done yet. I'm hoping to maybe try that in the future. But something like that is needed. That would be sort of the holy grail of dating, if we could actually directly date stone tools, right?
Yeah, no, that would be the game changer really for a lot of these things. Would it be the kind of thing where you would need soil samples from the local environment to figure out like what the ambient like fluorine is to do that calculation, or do we imagine it to be more homogeneous because it's associated with like rainfall or something like that?
Short answer is I don't know, but it would surprise me. I think the best case scenario would be a buried site and the same raw material, right? That to me would be, the best case scenario. If like we have the Allendale chert quarries on the Savannah River in South Carolina, we have the Topper site. It's buried. We've got a Clovis occupation. We've got Clovis tools. We've got early archaic tools. We've got some, later period. We might even have some of these so-called whole river possible pre-Clovis points coming out of Tauber. And they're all made out of coastal plain chert. They've all been buried under the same conditions. That is a scenario that seems like it would be ideal to test, the fluorine diffusion method of dating, but it hasn't been done yet. Something I hope to try to do at some point.
Cool. Okay, so one thing that we haven't gotten into, but I want to, just because I think you'll know better than just about anyone else that I would talk to, is we talk in the field a lot about changing hydrology between Paleo and Archaic period, where like we're working on sites where there's like a Paleo stream bed, cobble cores, and the stuff above it tends to be more archaic. The stuff below it, we're starting to get Dalton stuff. So this is something we talk about colloquially, but I don't know specifically like what's changing about the courses of river, because like obviously there's natural meanders that happen all the time.
Yeah.
But like, are actual river courses changing between these time periods, or is that an illusion based on the resolution we've got in the field?
I think they probably by the time of Clovis, most of these are pretty set. If you look at the work by David Lee and others, and you look at the LIDAR, you can certainly see evidence, and where we've done some dating, probably during the last glacial maximum, we had very cold temperatures. It was very dry. We had sparse vegetation. We had large braided river systems, right, with multiple channels, right, running through these huge floodplains, right. But that most of that seems to have transitioned, probably even by 16,000 to these really wide, sinuous, meandering channels, right. And a lot of that probably even more of what we have now, where you have really an incised channel, like I worked on the Tar River or the Savannah River, or we have the channels are cut down, they're incised. I think a lot of that relates to vegetation. When you remove vegetation, you're freeing up sediment, you're flooding the system with sediment, you create the braided pattern that we find, right, because it chokes the channels up, right. And if once you have climate conditions, and probably by the time of Clovis, we had essentially climate conditions like we have now, or pretty close to that anyway. And you had the beginnings of much more vegetation. You had more trees, more shrubs, and that locks in the banks of rivers. It doesn't let them move around as much, and so you lose the braided river system that we see during the glacial period. And you get more of this, really wide meandering channel type of system. So I think they were, from Clovis on, they were seeing pretty much what we see now.
Okay.
I was going to say a lot of the Clovis sites, there's been this idea that many of them have been scoured away, by meandering. That's certainly a possibility on our river systems.
Okay. There's another thing referenced in your dissertation that talks about lower sea levels contributing to faster basal water flow, if I understood that correctly. How is that right?
You mean in the rivers?
Yeah. So like the sea level is lower, and it seemed like it was implying that the river water was actually moving faster. The currents of the rivers were moving faster based on sea level.
No, I don't think I suggest that.
Okay. Young Chimick had said something similar to that to me in a class before, and it made no sense to me. And so I thought I was seeing the same thing, and I might have just misunderstood it based on being taught by Don.
Yeah, I mean, I think, again, getting back, I think really the way the rivers were flowing in most respects, until you get very close to the coast, is less about, certainly they're going to, if sea level is low, the rivers are going to try to, their base level they're going to try to cut down. But if the climate system is such that you have no vegetation or very sparse vegetation, you're dumping massive amounts of sediment, they're not going to be able to cut down, right? They're going to have to spread out.
Right.
So you get the development of these huge braided river systems. And so it's really more driven by climate, by
Right.
rainfall, than it is sea level, at least away from the coast.
Right.
Um,
So those braided river systems are now our floodplains, essentially. Yes.
yeah, right. That's
Okay.
right. Right. And there's multiple terraces. You'll see
Yeah.
older braided river terraces that have been cut at some point, and then another braided river terrace. That's certainly the case on the Tar River. Um, and on top of those, you'll get formation of, sand ridges, dune, sand sheets, aeolian sand sheets on top of braid bars. I think that's what we really have. That's the case for Barber Creek on the Tar River, Squires Ridge on the Tar River, Cactus Hill, probably very similar type situation. Um, so you do have aeolian sedimentation. It's much more episodic. Probably, certainly in the Younger Dryas, we might have had more opportunity for sediment to get blown around. But certainly in the Holocene, that mostly has been shut down again because the vegetation is locked in. We've got forest and grasses. I mean, and so unless you have a big fire and remove all that, whether it's in a river or whether it's being blown around or in a dune form, it's not going to happen. Until that sediment can be freed up.
All right.
By removing vegetation. Either through drought or fire or both.
Cool. Okay. Well, we've been talking for over an hour now. I don't know if you're cool to keep going. I got a couple more questions that I could ask you, but if you need to go, just let me know.
No, it's fine. Go ahead. If you have
Cool.
any more questions, that's fine.
So one of the comments that I got was asking about how do we envision things going if the Younger Dryas had not happened? So this is getting into like gross speculation, but this is,
Yeah.
it's an interesting counterfactual to think about, like what
Yeah.
happens archaeologically if this doesn't happen.
Wow. Yeah, I've never thought about that. Well, I think implicitly you would have to wonder, would we have had megafauna, either possibly even existing now? Some of the extinct megafauna, would they have survived, through the end glacial period? And frankly, I don't know why they wouldn't, because we see, if you go back in, the last 100,000 years, you see big swings in climate, both, warm and cold climate systems, and they survived all of those just fine, right? They may have had to relocate at times. But if we didn't have the Younger Dryas, event happening, I suspect we might have had, at least at some level, a hunter-gatherer adaptations for hunting, these animals might have continued for much longer, right?
I think about the horses and the camels, like because if North America had kept their horses and their camels, you've got possibility. It becomes much easier to domesticate animals if you can ride horses, and if you don't have horses, you can't ride them.
Right.
So
Right.
we then start to see some like manifestation of the same thing we see in the Eurasian steppe here in North America if they got to keep their horses.
Good point. I've wondered about that with the horses, especially because I think with the Pleistocene horse that went extinct it was small. I think maybe like a zebra sized, but probably something that could be, ridden, tamed and ridden. I don't know. That's something that I've thought about a little bit. But yeah, I mean, we don't know. Again, getting back, we don't know what the interactions were. For example, with Clovis and the Pleistocene horse, that's almost an unknown.
Yeah.
There are some sites where we found horse bones and Clovis material or Paleo Indian material associated with it, but we don't know what the interactions were. It is getting in more into the wild speculation at that point. But yeah, that's an interesting idea. If we didn't have the Younger Dryas event, if some of these animals survived into the Holocene, I mean, it's kind of getting back to the same thing with boats. I mean, humans, more or less do the same thing all over the world, given the chance, right?
Right.
So, yeah. Yeah, that's an interesting thought experiment, I guess.
Yeah. Um, I guess, and also, so what are you, other than this Greenland ice core project that you're going up to? I've been seeing pictures of you doing field work now. What have you been working on more short term?
I've done work with Jim Dunbar at Cold Springs in Florida for several years. That's mostly done now. We've got some other work planned. Um, I mean, I'm usually going around collecting samples anywhere I get a chance to go. If there's a profile of interest, I go and collect a sediment column from that profile. I take samples for OSL, whatever. What else? I mean, I've gone back recently. I'm looking at samples from Squirrels Ridge that I worked on for my dissertation. So I've got samples that I still have from, you know, 15 years ago. And I'm going back and looking at some of them um, for microspirals, for example. So I'm doing a lot of work, under the microscope, processing samples, uh, size sorting the different size fractions, using a magnet to extract the magnetic fraction from these, and then looking for these magnetic spirals. And so we do a lot. I do a lot of that kind of stuff. I'm working with people like Malcolm LeCompte at ECSU in North Carolina. He has access to an electron microscope, so we do almost weekly. We're doing electron microscope work, which I join remotely via Zoom. I send him samples. He looks at them under the electron microscope. We get images. We get EDS, elemental data for the microspirals. We've got multiple sites that we're looking at, from Kentucky, Louisiana, southern New York State, the Bowser Road site, Bowser Road Macedon site. We've got samples there we're looking at. We've got cores that were curated from at a repository in Nova Scotia. These are ocean cores. We've got samples out of them. We're dating forams, working with colleagues at East Carolina University. We're dating forams in those cores to isolate and identify the Younger Dryas in those cores, looking for spirals. So a lot of activity going on. A lot of it's not all field works. Some of it is stuff that's already been done. Right? It's
Right.
Curated samples, curated cores, that kind of thing. But all of this is just extremely time-consuming, tedious work.
Yeah.
The
I don't
microscope
is like really well understood by most people who don't do archaeology. Is like we go out and we do all this excavation, and then we might immediately actually use like 10% maybe of the potential of everything that we excavated.
Right.
It takes years and multiple people really attacking different aspects of all of these assemblages and collections and samples and stuff.
Oh yeah, yeah. I mean, I'm getting to the point where I'm almost fearful of doing more excavations.
Yeah.
Because you have to deal with the artifacts. You have, even if I've been working at White Pond in near Columbia in South Carolina since 2015. Very limited field work using volunteers, other professionals in South Carolina. And it's really interesting, but as you know, I mean, you go out for 2 or 3 weeks and you've got enough artifacts, that have to be looked at that will take many, many months to get done. Right.
Yeah.
So it's I don't know there's no way around it. Right. You have to, but it's why many of us wind up with these legacy projects, right?
Yeah.
That we're trying to get done. We want to do what's right. We want to get, the data completely analyzed. We want to write the report. But it's why so many archaeologists wind up with these projects that are not completed.
Yeah. And like my master's thesis was pure, legacy collections that were done, when my dad was 9 years old, 10 years old.
Oh, well, I mean, I think that's great. I mean, it needs to be done.
Yeah. And there are so many of those collections sitting on shelves that like there are not enough people doing master's theses and PhDs to actually
No,
get all of that
no,
work done.
no, not enough people, not enough funding to support these students. We need more of that.
Not enough days
So
in the hour.
none, yeah, no, there's not. So um, again, with me, I have a lab in my home, in my workshop at home, where I do all of the processing of sediments, the sieving and size sorting and ultrasonicating and wet sieving, and then drying the samples and bringing them in and looking under the microscope. It's just a tremendous amount of time to do this, and I don't have any students helping me out. I'm having to do this on my own, and of course, I have a few colleagues that are also working on either the same thing or other sites. So it just takes a really long time. And that's not even including the archaeology, right?
Right.
The archaeology, I like to go in and really, plot everything three-dimensionally. I want to have backplots and actually show exactly where the artifacts are relative to anything else I'm looking at. And as you know, all of that just takes so much time.
Oh yeah, like looking at what like Derek Anderson has been doing
Yeah.
at Topper, I think. Yeah, where
Right.
he's like
Yep.
doing the pitch and orientation of every flake to
Yeah.
reconstruct topographies and figure out where bioturbation has happened. And
Well, the refitting,
yeah,
right? He's done a lot of the refitting, which is incredible. Work needs a lot more of that needs to be done.
yeah. My friend Terry Barber, I think he did that for his master's work at East Carolina.
Okay, yeah, yeah. He worked at Squirrels Ridge, the
Right
same
on.
site that I worked on. Yeah. Mhm. So yeah, I mean, refitting is for getting at sort of site formation and bioturbation. That's hard to beat.
Yeah,
If you got enough artifacts and you got somebody that has the gift that they can see two different pieces and refit them together, that's fantastic. So my hat's off to anybody that can do that.
it's anyone crazy enough to decide to devote
Yeah,
themselves to that.
I did some of that at Flamingo Bay.
Yeah,
Around the same time that probably Derek was doing his work at Topper. And we had a hell of a time finding refits. But it's interesting that the limited number of refits that I saw, it's very similar to what Derek saw in terms of the average vertical displacement was less than 5 centimeters,
right.
which again, in these sandy sites, that's pretty good.
Yeah, that's not bad at all. That's way
So
better than what we might expect.
yeah, yeah. So really important stuff. A lot more of that needs to be done. But you need students to do it. You need funding to support those students.
Yeah.
So yeah,
And right now, certainly a lot of the funding is still coming out of um I mean, of course, there's like NSF grants and things like that, but like so much of
yeah,
the archaeology that gets done is excavation based on infrastructure projects, and that's
right,
just where the funding is coming from. So figuring out ways of kind of diverting that funding flow towards actually doing things with this material after it comes out of the ground is certainly a thing that needs to happen.
yes,
I've thought a lot ever since things like Kickstarter first came out, because people are interested in this and they're willing to throw dollars at it, figuring out like an ethical way to crowd fund research.
yeah,
Um, and it's another thing that is interesting to me outside of the actual science part of archaeology.
right.
Um, but yeah, I think that's probably a good place to leave off. Thank you
Okay,
again so much for coming on and talking with me about all this stuff. Um,
absolutely.
and I'm sure there will be like a whole backlog of new questions about this that we could talk about maybe later, or
Okay,
as it's certainly I'd talk to you again after like the Greenland project happens and find out
sure. Yeah,
what
yeah.
new information we get. Um,
Okay,
but I guess yeah, I'll sign off from there. Thanks.
okay. Stay tuned. All right.